Good evening to all, and welcome to the 38th edition of FAYA Pot 80. I can see so many new faces over here, and yeah, obviously we can see some familiar faces also. How did you come to know about FAYA Pot 80? Is it from the HR mail, or some of your colleagues or friends have already attended a session of FAYA Pot 80? So, how did you know about the event? Okay, maybe you might have known from your colleagues or from the HR mail. Okay, fine. To the new phases, I would like to ask, like, what do you expect from this 2-hour session? Like, what are the questions that might be going on in your mind? Is it going to be a purely technical event or technical session, or is it going to be an interactive one? So, what do you expect? Oh, both. Okay. So actually, yeah, maybe for those who are still wondering, what I can say is that, okay, fine, let's wait for the next 2 hours and figure it out ourselves, like what FAYA Potato is all about. So as an introduction or as a detail of FAYA Potato, I'll say that FAYA Potato is actually an open stage for all the technology enthusiasts to come along or to come over and discuss the latest tools and developments in the field of IT industry. So it's an open session, it's an interactive one, and it's a monthly session, and it happens on the first Wednesday of every month. So as we all know, today is not Wednesday, it's Thursday. It's because for the first time of the history of FAYA Potato, we have actually postponed the event from Wednesday to Thursday based on the request we have got from the community because of Eid yesterday. The journey of FAYA Potato, it has been a long one and it has been a successful one. And it's only because of the efforts and the hard work put in by a lot of people. And I would like to take this opportunity to thank and to recognize the efforts and the hard work put in by everybody, all the people behind this event, to make this a successful one, and yeah, and to make this journey an easier one. This 38th edition of FAYA Potato, it has yet another speciality, and we are really proud to associate with NASSCOM, the pioneers of trade and quality in IT industry. To start off with today's event, we have Techbites by Mr. Liju George. Techbites is a session that gives insight on the latest tools or latest advances in tools and technologies that has happened over the past 1 month. So I invite Mr. Liju for the Techbites.
Thank you, Arunima. Good evening, all. I am Liju George, working as a software developer in FAYA. So let's have a look on the latest technological updates of the last month. One is Apple Developer Conference happened last month, introduced new interactive features to to users, that's to iOS, macOS, watchOS, and tvOS, makes it more attractive. And OS is renamed as macOS, and the new version name is called Sierra. And opening up the Siri is a thinking move from Apple. Next. Finally, Apple announced its new name. It's not Nutella or Kerala's Nayappa. It's finally Nut. Next is introduce a new feature that allows users to authenticate their device by just a tap. With this feature, you need not type any text codes and makes the process much easier and faster. As a happy news, they are released a new version. It's mainly for HTTP via PSR7 and middleware, and optimized for PHP 7 and also support PHP 5.5 and other versions. And it's mainly next is introduced a new feature called identities. It's feature users to log in multiple accounts of the same site. This is container tab and That's a separate session, cookie, and login details.
Thank you, Liju. The synergy of this edition is a session led by Mr. Praseed Pai on machine learning, breaking the myths and hypes around. Mr. Praseed Pai works as a software architect in UST Global. His areas of interest include enterprise software development, engineering software development, computer graphics, and domain-specific programming languages. Besides being the author of SLANG open source compiler infrastructure, he is a co-author of a book on .NET design pattern by Packt Publishing. He has to his credit over 200 presentations on various technologies. I invite Mr. Praseed Pai to handle the session.
Hello, am I audible? Okay, before. Yeah, so the topic of my today's session is machine learning for the street program. Okay, so don't consider yourself as okay, who are from street. Okay, it is a metaphor coined by me to actually represent people who haven't gone to elite engineering colleges and want to do something which is considered to be advanced. Okay, so that is the idea. Okay, so how many of you have tried a hand at machine learning? Can you raise your hand to get the poll of the audience? Okay. So it is a hyped up topic is what I believe. Okay, so what happens is nowadays even okay ordinary taking a mean and median and or even correlation is considered as machine learning. Okay, so that is the situation which I am see I have come across. Okay, so this session is to dispel the myth that okay machine learning requires advanced mathematics and statistics. Okay, so it can be done by anyone who has got common sense. Okay, with bit of hand holding you will be able to even write algorithms. So that is the idea which I am trying to present here. Okay, so before I start I would like to highlight okay some things okay which every person who is trying to work with machine learning or data analytics should understand. How many of you heard of the term analytics? Everybody has heard about analytics, right? Okay, whenever you hear about machine learning, okay, it is called branch of analytics. Okay, whatever. So can anyone from the audience okay give a short on okay what analysis is? Anyone? Let's make it interactive. Okay, so that is actually data analytics. Basically, analytics is used by even military, right? Okay, everybody who actually tries to find out a optimum solution or for that matter, okay, to take decision based on some kind of data, you perform analysis. So the problem with analysis is, whenever you say analysis, it is all about breaking things into parts. You believe? Do you believe that? Breaking things into parts. And you decompose to a level where you cannot further decompose it, or okay, you have reached the level of granularity you want. So once you have actually decomposed the problem into series of small problems, you study things in isolation and then okay, you synthesize it back. So it is generally called analysis synthesis model of thinking. Okay. What is the problem with this approach? Can anyone take an educated guess? What is the problem with analytical approach towards problem solving? Anyone? Take a stab at it. Eh? So one answer which I got is accuracy. Okay, so can you just elaborate?
So what happens is I would call it glorified curve fitting. So good.
Okay. So the gentleman here seems to be a bit mathematically adept. Okay, he says that okay, analytics is curve fitting. To a certain extent, I agree with you. So the primary problem with analytics is it assumes that variables involved in the problem are independent. Whereas, so I will give you a small anecdote. If two smart people come together, will we be able to solve the problem? Okay, in half the time. 90% of the time, the politics between two will actually create a lot of problem, right? Okay, maybe you will take more. So in real life, variables are interdependent. Variables are interdependent. Okay. So if you do analytics, okay, so there is only limited applications for analytics in the real world. Okay, it will be a heresy because okay, this session is about machine learning, which is the primary branch of, it can be called a branch of analytics. The problem with analytics is analytics assume that variables are independent, whereas in real life, variables are interdependent. Okay. So if you consider interdependence into consideration, you call it systems thinking. You call it systems thinking. So analysis is all about decomposing the problem. So analysis is it's a reductionistic method. You reduce the problem into small problems, and finally when it is amenable, you solve it and then you stitch it back. Whereas systems thinking, which considers interdependence, is all about treating things holistically. So the problem with interdependence, what is the problem with interdependence? What is the problem with interdependence? Okay, so complexity is the primary problem, like he said. What is problematic with it? You cannot mathematically model it correctly, because moment you take into consideration interdependence, you are actually stumbled upon something called non-linearity, or the input doesn't add to output. Sometimes okay, you get ripple effect, or okay, you cannot predict the curve. Like he said, okay, you cannot fit a line. So what you have to understand is there is something called analytical thinking. People believe that okay, it can solve most of the problem, but whereas in the case, okay, because of the fundamental assumptions it makes, it cannot solve all the problem. You should go for system simulation, a system thinking, or a system approach to solution. So have you heard, see, most of the systems are simulated, right? They are not mathematically modeled the way the analytics is. So first, and the biggest takeaway from this session should be the difference between analysis and synthesis model of problem solving. Okay. So I think this, how many of you heard about the term reductionism? Reductionism. What is that? It's very important if you want to do science, right? Pretty much Western philosophy is based on reductionistic thinking. Okay, and holism is actually taking a step back and try to see the problem. So this you have to understand before you actually even learn machine learning or statistics or anything. Whenever you use mathematical modeling, element of linearity is supposed to be there. Okay, so whereas in real life, linearity is actually an approximation of the, so you cannot approximate it correctly as well. So let me move on to the second thing. Okay, what is machine learning? Okay, it's an operational definition created by me. Acquisition of knowledge or skills through study, experience, or being taught. We humans think only our species learn, right? So this particular phenomena is called anthropomorphism. Heard about the term anthropomorphism? So people say that there is God exists, right? Okay. So if monkeys think about God, okay, how God will be looking like? Okay, so that's so we are human-centric, right? Okay, that is called anthropomorphism. So it's a definition which humans feel that okay, only we learn. For that matter, okay, even snakes learn by instinct, right? They always leave a couple of eggs from the bird's nest, right? So that okay, next time it can actually get even more eggs. So this is by far, see, the first slide was about analytical thinking versus systems thinking. And then I gave an operational definition about learning. So this is the most important slide, okay, which I would like to tell. Okay, have you come across this definition? How many of you have seen this definition? Tom Mitchell's definition. It's a very famous book on machine learning. Try to buy this book. Okay, this is a bit mathematical, but this is considered to be a classic. Okay, if you want to do machine learning. Okay. So I'm not actually going to say you try to figure it out yourself. Okay, I call it PTM model. There is a program which runs against a task T, against a performance matrix M. Okay, he says something else, right? E. Okay, so PTM. There is a program. Yeah, programs always work on some kind of a task, right? Which works on task, which has got a performance matrix M. And if M improves with each iteration or each invocation of P, then that program is set to learn. Okay, so this is by far the most simplest definition you can get it. And I found it to be a very comprehensive one. I see, because once I got this definition, I understood that even Oracle database is also learning. Okay, let me tell you how. How many of you issued group queries in SQL? Average or sum? You have issued it, right? When you issue that, Oracle tries to figures out the other columns, and he computes even covariance, correlation, everything okay associated with it in one go, because accessing disk is costly. So that next time, if you are actually asking for a aggregate function, most probably he can take it from cache. Okay, he can remember it. Okay, that program is set to learn. A chess program. Do you think a chess program learns? Obviously, right? How can you beat a grandmaster? You have to encode lot of moves, right? Okay, so you look it up rather than try to compute the next move, right? So this definition is very important. So once again, I recap. I talked about analysis, synthesis model of thinking, and what are the limits of it. And I proposed systems thinking as a solution for the problem. System thinking, the problem is you cannot mathematically model. So since okay, analytical problems which are decomposed analytically can be solved with mathematics, or it is amenable to mathematics, people try to solve it, even if okay, problem is not linear. Okay, that is the funny fact. Okay. It's just an, how many of you come across this? A girl's pregnancy was predicted by target. Okay, before? Yeah, before even she knew maybe. Huh? Okay, so there are a lot of ethical issues associated with machine learning. Do you believe? It can be an invasion of privacy. Okay, just an anecdote. Okay, try to. That's a problem with there are some problem associated at the human level or the socio-economic level. Okay, moment you open any book on machine learning, you will see supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, deep learning, learning X, learning Y, learning Z. When you take a statistics book, you see mean, median, mode, standard deviation. Okay, usually, right? So the problem is okay. So rather than trying to take the usual step of defining machine learning algorithms based on okay learning models, okay, I would like to take a different step. Okay, I call it algorithmic techniques. Okay, rather than we will try to divide machine learning into statistical learning, Hilbert space methods, deep learning. These are all the three main techniques or methodologies we use to actually write machine learning algorithms. Okay, let me talk about each of them. See, in the first slide, did you see this guy, Hilbert? Who is he? Any idea? Hilbert is very important for us programmers in another context. Hilbert, David Hilbert. Anyone who has heard about him? Okay, so my friend, okay, Nigel has heard about it. Okay, since you are my friend, okay, you are not allowed to speak. Okay, so anyone else? Man, we are programmers, right? And this guy, see, next time when you get into Google, search for Hilbert's 23 problems. Hilbert's 23 problem. He formulated a set of 23 problem in 1900 at a mathematical conference, which dictated the research for mathematics for the 20th century. And out of that, two problems are central to computing and programming languages. Hilbert's second problem and Hilbert's 10th problem. Try to read about it. David Hilbert, he's a German mathematician. Okay, from the name you can actually understand. Okay. So when you say about Hilbert space, it is a glorified way to say about, okay, what this gizmo is called, this particular thing. Huh? Cartesian coordinates, right? Named after René Descartes or René Descartes, or French mathematician, right? And philosopher. Okay. So Hilbert space is a n-dimensional or infinite dimensional Euclidean space. Okay. Which has got certain mathematical property outlined here. So vector addition, you know, right? Okay, or else at least if you have studied 10th standard, you have actually done vectors, right? Or at least +2. Okay, then scalar multiplication. Okay, inner product is very important. In our textbook, it is called dot product. It's called dot product. Okay, and norm is nothing but length. So if you do some kind of a dictionary lookup, you can understand Hilbert space. It is nothing but, see, you understand line, right? Number line. You understand plane. Okay, XY, Cartesian plane. Then you understand space, right? If you have done computer programming, you would have even understood homogeneous coordinates as well. So maybe it's a restricted form of, or expanded form of 3-dimensional, or restricted form of 4-dimensional called homogeneous coordinates. So what happens is, you take data points and project it into Hilbert space and find the length and the similarity. That is how you actually do learning. Okay, there is a class of algorithm which uses it. Okay, this is what I am going to speak about it. Okay, if you have got any doubt after that, okay, we can actually speak. The second thing is statistical methods. Okay, so some time ago there were a lot of books on. There was a book called How to Lie with Statistics. How many of you heard about it? How to Lie with Statistics. Most of the time, if you take a look at it, statistical data, people, since we don't know, okay, much about statistical analysis, data is cooked and we won't be able to figure out, okay, whether something is correct or not, right? It's called statistical jugglery. Every year, after the month of February, okay, after the central government budget, there will be a lot of seminars, right, which is happening all over India. And then some expert will come and give a lot of statistics. People will believe that, okay, depending upon his political opinion, he will say X, Y, and then finally we all get confused, and we are going there to get confused. Okay, so that is the so statistical. Moment you say about statistical method, how many people purchased say soap and beer together? Okay, you can actually do just a frequency analysis, right? So you can do some kind of a learning there. Okay, then there is a famous story where diaper and beer. Okay, which is not a real story. That is what I have understood. So it's just like, okay, how many of you believe apple fell on Newton's head? It was a cooked up story. It was never happened. But if the person who imagined it was from Kerala, he would have actually imagined coconut he would have died long ago. Okay. So statistical method is the second kind of thing. Okay, I will show you some demos. And this is something called deep learning. Google is after it, right? How many of you hear Google deep learning or something? Okay, it is synonyms for neural network. See, the advantage with neural network is it works, but nobody knows why it works. So we can use it, right? So nobody will question us. Okay, but if you take a closer look, linear regression, it's actually an application of linear regression. Okay, we are modeling it in a different manner. So these are the three methods. One is statistical method, which based on frequency, probability, association analysis like correlation and regression. The next thing is plotting every point into some kind of a 3-dimensional or n-dimensional space and taking metrics. Metrics is a glorified way to tell the distance between 2 points. PageRank algorithm is using that. Are you aware about the fact that, okay, PageRank is Google's PageRank? Okay, or now they say that they have changed, but the basic idea remains the same, right? It's called vector space approach. Okay, so you take the document, you map it into some kind of a Cartesian plane or a Hilbert plane, and then you find proximity to what you are searching, and okay, what is there, you will find proximity, and then you will just print it. Okay, so these are the three methods. At least, okay, You will try, you are not hearing supervised, semi-supervised, unsupervised, all kinds of learning. Okay, so I think I have given you something. Okay, so this slide, it's not mathematically accurate, but it is meant for intuitive understanding. It's meant for intuitive understanding. Okay, I already told you statistical method, Hilbert space method, and deep learning. See, all you are doing is, okay, this is actually the data set or a one record, or a X is actually a data set, and it has got n attributes, x1, x2, x3, and then you have got weight, or weight can be considered degree of influence on the output. And in statistical method, okay, most probably it will be probability of each variable and how it affects the output. In the case of Hilbert space method, you know the equation for line, then you know the equation for space, right? So there is what happens is each of the equation has got set of coefficients depending upon the dimensions. So this weight actually will be the coefficient for the hyperplane. Hyperplane is nothing but, okay, you know what a number line is, right? You can draw it. Just now everybody studies in 5th standard. You know what a plane is, you can draw it. You can draw 3 dimensions, right? Or at least you can use computer graphics to actually simulate, okay, projection, and then, okay, you can actually get a feel of 3 dimensions. Can you plot 4 dimension or 5 dimension or 6 dimension? Even though it is not figuratively plottable, that notion can be extrapolated to any dimension. And the Pythagorean vector distance you used in the 2 dimension can be scaled to 3 or even to n dimension. So what they do is, okay, they generalize whatever property in the 2 and the 3 dimension and just project it. So this, even if I have written a term like hyperplane, you take it as plane and use software libraries to figure it out for you. I call it a functional approach to machine. So that is what I am trying to advance. And in deep learning, it is actually the weight of input neuron. I am not getting to it. If time permits, there is a software called FAYA. I will actually just show you one neural network. Okay. So you are you thorough with what I am telling now? There are 3 classes of methods. Statistical method, which mostly uses the familiar statistics and some kind of a sampling and inferential statistics. And then you mostly use vector space approach or Hilbert space approach, which are to find proximity between the entities. And then you are actually using something called deep learning, which is nothing but a variation of the previous learning methods you used. Okay. Okay. Okay, so it's a good question. Okay, so he has stumped me. Okay, so I have already told you. See, anything which is in the higher dimension can be piecewise decomposed into lower dimension. Do you believe that? Okay, that is how mathematicians solve it. At this point in time, I have already told you that, okay, most of the machine learning algorithms, okay, which out there handles linearity really well. And to handle non-linearity, there are some techniques. Okay, some of them I'll be able to show. So what happens is machine learning mostly, okay, I believe, is linear learning. So this is what I have shown. Okay, there are some algorithms like decision tree which can do non-linear classification, but they are based on the statistical methods. But it's not based on what the mathematical formula which I have given. See, don't take this formula as mathematically the most accurate. I was trying to just tell you that if you are able to figure out W1, W2, W3 to Wn yourself through the existing data, that program is set to learn. Okay, so that was the idea. I hope you got it. So let us talk about the first algorithm. Okay, so I have talked, see, anyway, I assume that most of you have heard about supervised, unsupervised. Okay, I'll just go to that and finish that ceremony which I need to take, okay, if I need to talk about machine learning. Okay. Supervised learning means, okay, before you deploy any algorithm to production, you gather training data. You gather training data and feed into the program. And once you have actually trained a program, how will you realize that, okay, it has already learned? There is a problem, right? You trained it. See, I try to train my kid about, okay, maybe coordinate geometry. He never gets it. How will I be able to figure out? Okay, most probably when he gets a mark, I'll be able to figure out, right? See, nowadays, kids there are who are very smart, okay, who can just memorize things and then, okay, get back to you. You'll feel that, okay, really they have learned. But actually, they might not have. Okay, so once you have trained your algorithm, there is something called test set. You run the algorithm, the trained program through test set. And there are some metrics which has been evolved in order to check whether, okay, there is correlation between what you have trained and how it performed on test. And there are variants of it. Okay, so in the case of supervised learning, you have got training data and test data, and you will train the model or the program using the training data. Once you have trained it, and you will try to test it on your test data. And if both training and test data do not represent the population out there, most probably your algorithm won't predict correctly. Okay, so that is supervised algorithm. So inside it, okay, you have got classification and regression. See, mostly if you take a look at it, classification is what you do mostly. Okay, any other sophisticated technique? Okay, maybe there is something called a priori. Okay, I got a C# implementation which I wrote for this session. Okay, which has got some more use. Okay, so what happens is, what I have found out is, okay, classification algorithms mostly work on something called categorical data. I will talk about it. And if you are actually trying to learn on a numerical series, you call it regression. Okay. And then, okay, there is actually something called association analysis. Okay, I will talk about unsupervised learning later. So in the case of association analysis, I told that, okay, what is the, see, if somebody has purchased soap and beer, okay, can he be sold, okay, bread? It's a hypothesis, right? You will try to see, okay, whether there is any correlation or association between two products, and if it is statistically significant, then you will actually try to give a coupon. Okay, retail people do it. And a priori algorithm is what Walmart used to make millions of dollars. Okay, so the supervised learning is about, okay, collecting training data and test data. Unsupervised learning, association analysis is about figuring out the correlation between the products or entities, and then trying to figure out, okay, some meaningful information from it. And unsupervised learning is actually a step towards supervised learning. Mostly there is something called clustering. And the best example I can think of is, okay, trying to find out the optimal palette for an image. Okay, images, you know, okay, true color images are there. How many pixels will be data points is required to plot a true color image? It depends, right? It can be 24-bit or 32-bit, depending if there is an alpha channel. Okay, so if you take a look at it, most of the images, there will be coherence between pixels, right? If it is a sky image, most of the pixels will be similar, right? So you can actually create a palette, and okay, you can disregard the delta between the palette and the actual pixel if it is within a tolerance limit. Okay, so you can use clustering, or else, okay, you can find clusters, see, people with similar traits using clustering. Once you have actually identified some clusters, you try to label it so that, okay, it can be used in the next classification algorithm. So that is the operational definition. I am not correct, okay, to the 100%, but this is the basic idea. And then, okay, there is something called dimensionality reduction, okay, which I would like to talk once again. What is dimension? Dimension is a glorified name for your fields in a dataset or attributes in a dataset. Okay. See, will I get electrocuted while I am traveling from here to UST Global office? Requires 200,000 variables to be evaluated, right? Ideally speaking, to get the, okay, the most accurate answer. Will you do it? You'll die right before that. Huh? Okay. I was just making an approximate figure. Okay. So 200,000 means, okay, you can actually even think that, okay, humidity has got an effect. Temperature has got an effect. You have to evaluate every variable, right? In order to see whether, okay, what is the path I should take to go from here to there without electrocution. Okay. Remind that, okay, you want to find it. See, we won't do that. Okay. Humans use something called bounded rationality. Heard about the term bounded rationality? See, we say that humans are rational animals, but there is a bound on it. Degree of analysis you can do. You cannot do everything. So likewise, even if there are 100,000 variables to a problem, only 3 or 4 will be significant. So there are cluster methods available which can actually find out that. Okay. So there is something called principal component analysis. There are a lot of things. But at least, okay, to sum up, there is supervised learning where, okay, you gather data to train the model. Once you have trained it, you actually test or you cross-validate against different data sets and find out some metrics to see how effectively it is learning or whether there is overfitting or underfitting. And that is how you do classification. For regression is actually a glorified form of classification where numerical values are. When you say class, it is actually good, bad, or ugly, or A, B, C, D. Okay, that is a class. Okay. And then association analysis is about, okay, how to find out clusters. Not clusters, how to find out association. Okay. This is a data set. Okay. Rule-based classification is the most simplest algorithm I can think. Anyone can write it. We always write it, right? How will you verify that, okay, whether a check has bounced or there is potential to be bounced? You will see the bank balance of the previous checks issued and then, okay, you do some kind of a rule and then find out that, okay. So looking at this data set, a subject matter expert can enumerate these rules. Do you agree? And you can encode in a language like Python and call it from C++, Java, and then you can actually do learning, right? But it is actually a crude form of supervisory learning. But there are techniques where you can actually find out these rules automatically. So did you understand? So you learned the number 1 algorithm. Did you learn any mathematics to learn this? If you learn if else while loop, select, update, delete, you can do it. Okay, so rule-based classifier. So this is a pseudo algorithm. Okay, at least. Okay, association. So rather than going to decision tree or some other classification algorithm, let me talk about association algorithm. This is very important algorithm. If you are working in retail industry, okay, some of them, okay, who happens to be from my company works with retail segment, okay, it is very important for them. Okay, let me start. See, I am actually trying to see if time permits, I will show some mathematics. Without that, okay, you have to have, there are some rituals, right? Okay, we need to perform in every machine learning session, but I will try to keep away myself from mathematics to the extent possible where I will be trying to challenge you with logical anecdotes to learn machine learning. Okay. Can you read this notation? What does this say?
Probability of y given x.
Yes. So it is actually called conditional probability. Probability of y given x. So we are making an assumption that, okay, here probability of x will be the denominator and actually probability of y will be the numerator, and then the events are interdependent. Okay, so diaper and beer is one, right? Okay, wherever diaper and beer, diaper is, beer is there is diaper, right? What about milk and bread? It is 0.7. See, there is something called support and confidence. I will show you. So this is the minimum vocabulary for a priori algorithm. See, it's not a priori algorithm, at least doing a heuristic statistical analysis on the data. You agree? You understood this? You take the data set and then count the frequency and probability. It's very easy to do. It is just enumeration. Okay? You got it? So let me get into deep into algorithm. Okay, this is a slide, okay, which I lifted from a presentation. It is not created by me. Okay, so let me talk about the a priori algorithm first. Before you study a priori algorithm, you should understand the notion of support and confidence. Notion of support and confidence. So whenever see a new government comes, the copra traders will say, okay, we require support, right? We require support. Support in the case of a priori algorithm is the significance of the count or frequency. Significance of the count or frequency. And then there is something called confidence. Confidence means, okay, so take a look at it. See, this is See, this is very important. Understanding what support is. You actually take the number of tuples. Tuples means rows, right? You take the number of rows in the data set and you find out, okay, see here they have actually given it as percentage, okay. So there's a slight anomaly in what I told. I told that, okay, support is actually frequency, but actually they are actually taking relative frequency, but mathematically there is only slight difference. Okay, it's a matter of scaling it. Okay, and then confidence is, okay, how much. See, you have got a subset of items and then you are trying to recommend a item from a superset basket. So from subset to superset, what happens is, okay, the number of count with superset will be less than the subset, right? Frequency of bread and butter is 200. Frequency of bread, butter and sugar will be always less than that. Do you agree? So the ratio between the 3 item and the 2 item has to be computed. And if it is more than 60% or 70% only, you should take into consideration whether it should be recommended or not. That is the basic idea behind it. Count support gives you the frequency and confidence gives you the relative frequency. Okay. And let me, you got it, right? Okay. There are shoes, shirt, jacket. Okay. These are the 3 items. And then, okay, they are actually computing support and confidence. Okay. See, usually it is some kind of a thumb rule. Okay, if there are 10,000 transactions, to be considered something to be statistically significant, I would assume that at least 500 transactions should be there having that data. It's just a heuristic. It is human expert judgment. Yeah, but technically it is possible to find out, okay, statistical confidence through automatic means, but too often, okay, it is done by the data scientist or the data professional who does it. No, see, confidence is actually the relative frequency, and then support is actually the count. Okay, that is how I have implemented, at least in my algorithm. Yeah, because, okay, the businessman wants to give promotional coupons with people having 60% correlation or 70% correlation. Yeah. Got it? Okay, so let me. So this is an item set. Okay, this is transaction ID 134, 235, 1235, and 25. I will show you a C# algorithm. Okay, so I count the frequency of 1. Okay, 1 is available in 2 baskets, right? Then 2 is available in 1, 2, 3. So I just count the frequency, and my support should be 50% or 2. Okay, how many depending upon the items? Okay, 4 items are there. Okay, so at least there should be 2. Okay, so these things, anything more than 2 qualifies. So this number 4 is dropped. Okay, so I have got the next thing. I iteratively find out. Okay, so I generate the 1, 2, 1, 3 like that. Okay, I generate the combinations. So basic idea is, if there are 10 items, there will be 1024 combinations. If there are 8 items, 256 combination. What I am doing here? I am finding the possible subsets. 2 raised to n. If there are 3 items, 8. So 8 possible. See, we are disregarding unit here. We are only taking into consideration combinations or items. You are enumerating it. So then you need to actually find out the frequency of it, and then here also you are sieving it. So this is how the algorithm first actually it scans for the transaction with ordinality one item. Then okay, I sieve out okay the things okay which are less than the 50%. 50% come or 2 means there are 4 transactions. 50% means there should be at least 2 transaction. That's why I said that okay, count is also a good option. And then okay, I generate the next combination like that. Okay, I found out see anybody who has purchased okay item number 1 can be recommended 3, right? Because it has got significance of 2. Are you getting me? So by finding association, you will be able to see it's a simple algorithm, and incidentally, it is invented by 2 Indians, one Agarwal and Srikanth. Okay. So this is called a priori algorithm. Walmart made millions of dollars using this algorithm. Okay, so let me move to so I will run this program. So this is the rule which my program created. There is a small bug in this program, but okay, it actually prints certain things multiple times. But if you set a filter, okay, so what happens is coconut, soybean, and sugar. Those guys can be recommended banana because support is 793, or at least 1/10 of the transaction. That's what I have taken. 8,100 transactions are there, and then confidence level is 0.71. So this can be recommended. So these are the rules generated by this algorithm. Did you understand? What I did was, long ago, I had created a program to calculate subsets. How can you calculate subset of a series of items? Anyone? There is a simple way. Have you ever tried to compute subset of a set of items? You haven't written any combinatorial program so far? Yeah, a string has to be but most algorithm beyond 20 items, okay, it is not tracked. Okay. So basically, idea is okay. You have got 3 items, right? So how many subsets are there? 8. So you count from 0 to 7 and find out where the bit a bit is on. Split that particular. See, you have got 3 items. Imagine that okay, A, B, C. Index of A is 1, index of B is 2, and index of C is 3. Sorry, 1, 2, 4. And then what you have to do is, you just actually take the bit pattern and split the corresponding item. You will get the subset. So what I did was, I generated 8,000. See, next time when I run this, you will get a slightly different recommendation set because this is not based on actual transaction from any supermarket. What I have done is, I generated my transaction using subset algorithm. What I did was, there are 8 items. So I created a random subset. And then I was able to generate this data. After that, I did frequency and
all the confidence that will be balanced. Okay.
yeah. So that's what. Okay. So it's called error of omission and commission. Okay. Most of the time things cancel out.
Yeah, you need to bias.
Yeah. So there are actually Gaussian random numbers. Okay, with actually mean and standard deviation. You can do some jugglery. But what I did was plain random number gave me the best result or best entropy. So I get a list of transactions. I generated the possible subsets and looked up all subsets in the transaction, and I generated the support and the confidence. Did you got it? Get it?
But if you have maximum entropy or if you have equally likely sets, how can you generate pattern out of it? Because there is no information.
Yeah, so that's a good question. So basic idea is, there is a hypothesis that the market basket see what people purchase, and or at least statistically it is found out to be has got some correlation with what they might purchase. So it is based on an assumption. If that assumption is not held, the people from Mars and others are actually purchasing without any pattern, okay, you cannot actually do it.
Yeah.
And what
should be something like, for example, the initial set should not be random. If it is purely random, then there will be no pattern to find it.
But in computers, you cannot create pure random numbers, right? Okay, you get pseudo random numbers. Okay. But for some reason, okay, that's a good question. But I really got samples where I could actually find out, and most often milk, sugar, and bread comes together. I don't know. Okay, you got it. Okay. It's very funny thing, but at least you got the crux of the idea. You take the items and then generate. See, usually you will actually get a data set from a supermarket. You do parsing and then you create data structures and then you find out the support and the confidence. I opted for count. Frequency is not that different, right? You have to just scale with total amount of transaction. Okay, so you got it. So you have learned how many algorithms now? 2. Yeah, the transactions. Okay, yeah. Yeah, not actual. See, actual algorithm is based on frequency and the degree of confidence. Yeah. I will give you the code, okay, those of you who are interested, okay. Maybe at least I will put it in GitHub. I need to do some formatting because it's C# code, it is spaghetti, okay, I wrote it in a couple of hours time, just to prove that, okay, otherwise, okay, oh, you are barking about machine learning, okay, have you written anything, okay, at least I can tell that, okay, tell that I have written something. Okay, let me return back to slide. So it's 5:50, right? So I should park it now. Okay. So I will go to the next algorithm. Are you with me so far? Okay. Yeah, I am going to park it now. After that, I will show you decision tree algorithm and naive Bayes and some idea about linear regression. Okay, so this is a topic which is supposed to be. First of all, I would like to tell you that my interest in machine learning is rather cognitive than to do something with. So far, I haven't done much with it. I have actually tried to learn because, oh, you are a programmer, you cannot learn it. Okay, that's what the challenge which I got. How many of you face that? Okay, there is a machine learning mafia out there. How many? Can you raise hands? Only certain people, chosen one can do it. Okay, so I want to dispel this myth. So this is for us street programmers. Okay. Okay. So after the coffee, we will continue.
Excuse me. Okay, so okay, you're getting your snacks. Okay, can you please be seated because we have something else during this break session. Okay. Okay, so if you please take your seats. Okay, so while you're munching on your biscuits and the coffee, we'll just have a quick interactive session or something. I'll just ask you few questions, and if you know the answers, you can just raise your hands and okay. So, and if your answers are correct, obviously you'll get some goodies from FAYA. Okay. Okay. So the first question is, which is the world's first web browser? So those who know the answer, just raise your hands. And it's first come first. Sorry, I saw him first.
World Wide Web.
World Wide Web. Yes, it's the correct answer. So may you please introduce.
Hi, I am Jiju. I'm Matthew. I'm working in UST Global.
Okay. So the world's first web browser is World Wide Web, and that's the correct answer. So you get a pen. No, it's actually it's a World Wide Web. Even though it doesn't support the graphical, it's not graphical. Yeah, it's a graphical web browser, but the World Wide Web, it doesn't support a graphical thing. But it's the ultimately the first web browser is World Wide Web. Okay. Actually, it's renamed to Nexus now. Later, it was being renamed to Nexus. Okay, next question. It might be tricky, but okay. Which is the software company which was nicknamed as the Big Blue? Those who know the answer, just. Okay.
IBM.
IBM, that's the correct answer. So, will you please?
I am Rohit Krishnan. I am from UST Global.
So all the prizes are being backed by the techies from UST Global. Okay, so you get a FAYA hat. Okay, so this question is really easy, and it was even mentioned for the Techbites. So those who know the answer, just raise your hands. Don't tell out the answer. Okay. What is the name of the latest version of Mac OS? Like seriously?
Sierra.
Sierra, yeah, that's the correct answer. So you get a FAYA hat. So that's it. That's all for the day. Thank you. So you may continue.
Okay.
Okay, so since the coffee is getting delayed, we can actually use this time for a very informal and interactive question answer session. So if you want to ask any questions on irrespective of technology, or even if you want to ask anything related to the session till now, you may please ask. It's open for all. And Praseed Pai will be.
Maybe I will take a stab at if you have got any. Okay. Okay, since I am not getting any question, okay, I will give you some math game. Okay. Okay. Nikhil. I'm not saying that, okay, if you take a look at it in any textbook, you have got it. Okay, too often you associate it with your sleep. See, when you study an algorithm, when things crop up, and then, okay, how many of you have really tried to study statistics? Mean, median, mode, then dispersion, you will sleep, right? Have you ever done anything with probability or tried to study beyond that?
Yeah, when you want.
When you take some Coursera course or something, you might do it. Okay. Okay. I don't know. So far, I have seen that, okay, people have used it for. Okay, forex market. Okay, I've got a small contention there. Okay, so no, it's based on my experience. Okay, he might be correct. How many of you heard about this software MetaTrader? MetaTrader. Okay, MetaTrader is a software. Okay, 2011, a stockbroker from Cochin, a forex broker, wanted me to write 3 models on MetaTrader, and the language is something called MQ4. Okay, so what happened was you will get the training data or the data for the last 10 years against each currency. So what happens is it contacts a portal and downloads the data. You will be able to get a you'll be able to get a you'll be able to get a timeline view or a time series. So already I got 3 models from an American gentleman who has written a book on MetaTrader. Okay, so I was trying to tweak that. So essentially I was trying to fit a line. Okay, initially I started, and then I could actually work on, okay, maybe 1 month and all it is giving correctly, and all of a sudden it breaks. Then after 2 months data it comes back. So what happens is, I understood after playing it for 1 week that there is no pattern in data. There is no pattern in data. It can happen, but your boss will say, find out pattern. Have you got it? So that is why I said machine learning is not useful everywhere. 3 conditions has to be satisfied. First, there should be pattern in data, and traditional mathematical analysis should fail, and there should be tons of data, and we may hope to get something. So after that, I'm a bit skeptical about whenever I hear about machine learning. So how many of you read book like Fooled by Randomness? Fooled by Randomness. How many of you have read that book? Okay, 1. So try to read that book. Or else, okay, in financial services, this big data and statistics is sham. It hasn't worked. Okay, based on my my interaction. Okay, there are. See, I'm not saying that D.E. Shaw hasn't made money through arbitrage, through trading initially, but nowadays there is no scope for much. Oh, so it's actually I will get sleep. Okay, so whenever you say about finance. Okay, so now how many of you heard about the Black-Scholes option evaluation formula? Okay, so there is a formula to evaluate option. If you take any mathematical finance book, second chapter, it will talk about geometric Brownian motion, drift, all kinds of sigma, standard deviation, integral. And unfortunately for us, in 1973, someone found out a closed form solution. Closed form solution means a differential equation which has got an algebraic formula or a well-defined formula as solution. But those kind of things only happen in our textbook to make us pass exam. But in real life, 90% of the differential equations do not have a closed form solution. A gentleman by the name Robert Merton actually found out he was awarded Nobel Prize for Economics in 1997. And they created something called long-term capital management fund, which gave 58% return for the first 5 years. And all of a sudden, in 40 days time, they lost everything. And there is a famous book by Roger Levinstein called When the Genius Failed. So take a look at it, and then see, there is something called, see, it might have, see, there are a lot of actors from Alua, okay, Nivin Poli, Dilip and all, okay, so just because they are there doesn't mean that all the people from Alua can get into film. Yeah, okay. That's why I told, okay, so what happens is, moment you see finance, you will see, you know, how many of you can actually reason why mathematics is supposed to be effective in finance? Why mathematics is supposed to be effective? You know, there's a funny fact. When you calculate the compound interest formula, if you are actually doing something called continuous compounding or continuous time finance, the scaling factor E becomes e to the power of Rn. E is the base for the natural logarithm. And if you take a look at it, most of the physical phenomena has got E as coefficient in it. So what these people do is, okay, they hire physicists and then they tweak E, R, T in various dimensions and hope to see something coming out of it. But much has not been come out. That is what I have heard. Okay. I was working with a company called InvestNet. Our vice president was actually running the D.E. Shaw's mathematical finance department. He considered to me one day that, okay, you can create models, but models which effectively works are very less. And if it has worked, okay, it has because of chance. So it's not that, okay, otherwise all mathematicians would have been very rich by now, right? So shall I start? Okay. See, whatever I say here doesn't have anything to do with UST Global. It is my personal opinion. Okay. Maybe our company might be selling a product which says that okay, you can predict market. Okay. So I don't want to be in trouble. Okay. So the next algorithm is decision tree classifier. How many of you seen the serial Ashwamedham? Well, not serial. Okay. The program Ashwamedham in or else okay, they just got an English equivalent, right? What is that? Oh, a person will see. He will ask you to guess a person or event or something. 20 questions. Okay, there is a program in the West called 20 questions, and in Kerala there was something called Ashwamedham. So there is a guy called Pradeep who will ask you a series of questions, and finally he will be able to figure out okay whom you have actually imagined. You cannot just imagine any other person. There are judges who you are supposed to know everything about the person. So that is where Pradeep is going to score. Okay. So what he does? First, he will ask, okay, is he an Indian or a person from the West? So he has sieved the total data set, right? After that, he will ask whether it is a male or female. Okay, so not even half. Okay, gender-wise it is half, but maybe if it is for certain events and all. Okay, maybe scuba diving. Okay, there will be women, but 90-10 or something. So by rapid sieving, he will be able to figure out okay who he is. So decision tree algorithm is an algorithm which works exactly based on that principle. Okay, so let me show you how. So this is the data set. Okay, it's not when I scaled it. So this is the tree which they created. Okay, this is called the weather data set, which is very famous. If you look at if you search the net, you will find it something called weather.csv or weather.arff. You will be able to see the data. So the tree which has been automatically produced out of this is this one. Okay, if it is overcast, if it is rainy and then humidity is high, he won't play. If it is rainy and humidity is normal, he will play. So yes will show you whether he will actually play, or Y will show you whether he will play. Okay, so what happens is whether he will play. So by looking into the data set, he will actually split the data set and figure out this tree. So this is the basic idea. When a new data set comes, you can run through it, right? If you take a closer look at it, it is very close to the rule-based classification which I told. Decision tree induction algorithms generate rules. Okay, so rather than trying to give it, I will show you a small 10-line Python program which does it. Okay, I will first show the data set and then 10-line Python program.
So if you add more data, does this decision tree change?
If you add more data and features are independent, okay, tree will be much more closer to the approximation.
So basically, if there is any new data coming in, it will be
it is a supervised learning algorithm. Yeah, you have correctly inferred it. Huh? Yeah, it's a supervised learning.
Does the order in which you feed the data alter the structure of the tree?
No, see, there is this particular algorithm is called decision tree induction. Okay, what is meant by inductive reasoning? You test, you put some data and see okay whether it works, right? Okay, so decision tree induction algorithm tries to generate different splits and find out which split is giving you the maximum information gain, and figure out a tree which will be not the most optimal one. It is not the most optimal one. In inductive learning, errors can happen, but he will tries to reduce the entropy or measure of disorder. Okay.
So that means the order, the parameters, for example, temperature, humidity, or any order, the order in which you process that will also determine the order in which you create values.
No, if you are actually creating a naive tree, you are correct. But decision tree induction, yeah, it actually processes all combination and finds out okay which split gives it maximum information gain. Okay, so there are matrices like Gini coefficient in order to see. I'm not going to get into that. I don't want to complicate the discussion. At least you get it right. Give the data set. he'll be able to fit a model to it. Okay, let me show you in scikit-learn. Okay, how many of you have studied Python? Okay, Python need not much study. You did not study much, right? You can just code. Okay. There is a, okay. He's referring about a program which I wrote called hello.py, based on an idea from a guy called his name. He's from Cochin. Okay. No. He wrote. Okay, wrote in UST. Okay, so it's based on my idea. He created something called hello world, where he will write a minimum program, which will actually do, which will have most of the language construct in it, which does small things. So what happens is, if you want to understand the syntax of for each, okay, you just go to the program and then control this. So it is actually a repository of course. I created an expanded version of that called hello.py. Okay, so let me get into the. So now we will go to the command line. Okay. Okay. So the question is, okay, in this particular thing, when do you stop creating the decision tree? So there is a thing called pure node. There is a thing called pure node. If the target variable is homogeneous, that means, okay, when you descend down the tree, at some point in time, you get everything as yes or everything as no. You can stop there. And rest of the time, you can actually compute the degeneration of the tree or the length of the tree. And if you are not gaining much information after the next tree, you can stop there. So there can be some inaccuracy. And you won't produce the most optimal tree. Otherwise, that's why it is called inductive learning algorithm. It is usable. See, decision tree, people do not deploy the model just by training. They tweak with it, they play with it, they train and test with different data sets from different sources, and they will do cross validation, all kinds of things to do, and there are metrics or measure available to see the efficacy of the model. Only after that they will.
So, sorry, Praseed, there are some live viewers, they are unable to hear you just because you are not.
Okay.
So essentially what you are saying is that this is not very supervised machine learning. This is software reading a human being to learn.
Okay. So maybe I think you are too philosophical here. Okay, I don't want to get into our argument. Okay, so there is actually wisdom in it, but for the sake of discussion, okay, we will fool ourselves into believing that okay, it learns. Okay, so that okay, we can continue with our lesson. Okay, so what really happens is, okay, that was a good question. So when you split down, so this is a pure node. At the first split itself, it understood that okay, there is no need for further split. Okay, so let me go to. So this is a simple data type created by me. Okay. You have got the ID of the person, name of the person, gender. Gender means okay. 0 means male and 1 means female. And then age as 44-25 like that. And then you have got salary. I have given the same thing. Reason why I didn't put some names because of privacy reason. A, B, C, D are labels. Then you have got salary. Then whether he is married and default. So this is a data set meant to predict whether someone should be given credit cards. Someone should be given credit cards, or should be spend marketing budget on, or should be send promotional offers to whom. Okay, so you got a data set, right? In real life, you will have maybe 1,000 or 10,000 records. This is just a simple thing. You can actually, looking at itself, you can actually see first, okay, whom we can actually, who are not. See, when you talk about credit card companies, you should give credit cards to people who default, right? Rather than who remits it properly. They won't be able to get any additional revenue. Okay. So what happens is, okay, anybody who is yes should not be given credit. Did you get me? You should not be given credit because credit card company is not going to gain. Okay, by looking at it, say if somebody is less than 25 and he is not married, he doesn't remit properly. So give him more credit cards. Why? You will get more revenue, right? And you have to have suitable number of goons around, okay, in order to coerce him into giving, okay? But you got it, okay? By inspection, if there are only 10 or 20 or 50 data records, by inspection, you will be able to learn and then you encode it as a rule-based classifier. But in real life, you will have thousands of records. And how many attributes are there? 3, 7 attributes and 11 records are there, okay? Let us see a Python program which can determine the credit worthiness of a person. Okay, forget the name base, okay, but great. Okay, the program execution starts from here. What you are creating is something called a data frame object, which is available with Python. Okay, you are actually reading the CSV. CSV stands for comma separated vector, the most ubiquitous format, and okay, you can read it in Excel as well. So you can use Excel to create data set easily. And then okay, you so you have created Python is a dynamically typed language. Okay, you won't actually give any type. Okay, so you will be assigning it. Okay, you are just instantly doing a decision tree classifier, and these are all the columns: gender, age, salary. So I am saying that out of the 7 columns, 4 are determining the output. What are they? Gender, age, salary, and marriage, right?
Is the default supposed to be most important?
No, that is what you are trying to predict. How? So if you take a look at it, labels are the output values, and features are all the it's a subset of records, or not subset. It is actually a subset of columns in that record. That is what your feature is. And you are just printing labels and features. And all you have to do is give the features and labels, scikit-learn will actually fit a model. You will actually fit a model. Once you have fit it, okay, this is what you are going to predict. Serial number is so gender is 0. That means male. He is 50 and his income is this, and then he is not married. So should he be given credit? Okay, so what I do is after that you are just saying predict. So you can actually predict whether it is yes or no. So basic idea is you take your data set and specify to the scikit-learn the columns are of interest, the columns of independent variables, and after columns of independent variables, and then okay, you generate the feature set and the labels. So that is what I told you. There is a element of human judgment should be there. But there are tools like dimensionality reduction techniques which can do analysis on data, but categorical values has to be converted into numeric. So there is something called dichotomy. So there are a lot of issues involved. So
How more like human people are teaching this? Machines are not learning it.
no, but machines are supposed to infer data, right? Based on the trace. It is not the way you write a typical program. That's what you mean to say. Okay, so whether it is learning or not, okay, then you can actually write to machine learning pundits about okay how you should act. Tell me.
because the data set is so small, it seems to be pretty obvious.
Yeah, but if you have got 10,000 records and 89 columns, what you will do? And 25 of them can be significant.
Yeah, but then you have to go through the exercise of defining which of the 89 are significant.
25 are significant. That you have to do. So that is where exploratory data analysis comes into picture. You load the data into some kind of a math lab or statistical tool, and then you play with summary statistics. Okay, whether see most of the time. Okay, one thing about decision tree you have to know is features has to be independent. Features has to be independent. Otherwise, you will be having double counting. You have to see the problem with this. See, go and take any statistics textbook. Moment you teach probability, so there is actually a sigma will come, and lot of things. Not only you have got additive terms, you have got subtractive terms as well to minimize double counting. So this problem can come here. So the data set should be independent. Okay. So I have to create a model. I don't have a model now. Okay, so a data set now. Okay, but I will be able to do it. Okay, it should be in some kind of a workshop. So basic idea is whether you are see there is something called Boston housing prices. Okay, but I need to look into the dimensions within it, and unfortunately I don't have.
It is, as you said, it is just like that. There is one like Indian square feet, and other one is meters, and then the price in action.
Again, this is again more human people coming and saying that.
Yeah. See,
No, the machine can't tell, right?
no, the problem is, okay, then the question comes is, there is chess programs. Okay, chess is called the Drosophila melanogaster of AI. Okay, it is a fruit fly of AI. But do you think that chess program is learning the way a human does? It is brute force and then memorization or memoization. So you are having an anthropomorphic view of learning. Okay, that is what I was actually telling in the first slide itself. Never assume that, see, learning means in a traditional program, you throw away the information you have already accumulated mostly. In this particular case, historical data as well as correlation and the association between the variables are tracked, and then okay, you are actually making the programs better. And the hope is that someday, okay, by studying you will become a scholar. Okay, like that, okay, this program will be able to reason in the most efficient manner. But still, there are limits for machine learning. I have already told you mostly it is a linear affair. Okay, so that problem is there. But decision tree algorithm, it's very easy to hold. Even if you have got 10,000 data, the Python template for doing machine learning is same. Okay, let us recap.
How relevant is the size of the data set for this type of algorithm?
Okay, see, first and foremost, if you want an industrial strength implementation of a decision tree with millions of records and thousands of columns, I don't think NumPy will be very, scikit-learn is very slow. It is meant for prototyping. If you take a look at R, it is the story is same. Maybe you should actually use SPSS or SAS data miner or Hadoop. You should actually program custom infrastructure to do it. So Hadoop has got a library called Mahot, which is good for offline processing, and there is something called Spark, okay, which he was mentioning, okay, which he is working. If you want to learn on a stream data, but decision tree is mostly based on the offline analysis. I don't think that it is based on data size is not. See, then okay, there is actually the problem of step. Okay, so yeah, see, there is a particular theorem in stat. Yeah, but that doesn't mean that you have got more and more data, you will predict correctly. The data can be skewed.
If there is a pattern, then the more the data, the better.
Pattern will be out there, but your data set is actually based on sampling, which is which can be availability sampling.
So as the data set increases, that is the training increases, the accuracy will also get increased.
But to a certain extent, see, that is where in statistics, how many of you have heard about a notion called central limit theorem? What does that say? If you have got more than just 30 samples, you will be approximating to the population mean. So what happens is, by having additional data, see, the advantage of central limit theorem is, no matter how the underlying distribution works for the actual data in question, if you take a sample, it will be normally distributed. So that is an amazing consequence. So even if you have got 10,000 records, you can always take a representative sample of maybe 100 records and easily predict. And there are tests available to do correlation between the sampling statistics and the population statistics. Okay, so she was mentioning about a method called principal component analysis, where, okay, so you compute mean, and then, okay, you subtract the mean and you calculate something called covariance metrics. So there are some tricks available. Maybe if you are using a software library like scikit-learn, it is actually 10 or 11 lines of program. But in order to decode it, why it works, it may take, okay, a week or two, or maybe I think you seem to work with machine learning, right? Okay. Yeah, so she seems to work with it, because she might be knowing better than me why it works. Okay, but basically the idea here is, by having more data, at least my personal opinion is that it is not going to add much, but it will add if there is no, see what happens, if the data is too entropic, more data can actually result. But if for homogeneous data, I don't think that, okay, beyond a certain point, you will be able to gain anything.
It's an efficient way that you ultimately pay, like if it's not balanced, then that means your data set is not.
No, but need not be balanced. If there is no balance in the data, why the tree should be balanced? Tree, see, balancing of the tree is for the access of the data in the traditional data structures. I don't think, okay, maybe you can correct me if I'm wrong. In real life, see, the tree which I showed you earlier can be skewed, because maybe, for example, in certain states, people of certain community only go for chartered accountancy training. So if you take the case of Tamil Nadu, so Tamil Brahmins, okay, so because they don't have any reservation, all of them try to become chartered accountants. Okay, the data set will be skewed towards that. Okay, so it need not be balanced. Okay, so if you are creating the balance, okay, you are actually involving yourself in the data out there. You are not doing the analysis, you are tweaking the data. So that is what my understanding is. But scikit-learn has got scalability problems for sure, and it is not that fast. Even for, see, I will show you, when I run this, it will generate a PDF file. Okay, I'm using something called Graphis to generate the tree. Okay, so what it does is, you just actually load the data set, and then you create the, see, it can be a random forest as well. Random forest is an algorithm where you create lot of trees and actually find out the averages of the prediction. So you take a classifier here and give the labels and features. You just actually use the fit function, or you use the fit function to fit the model to data, and then you can do the prediction. That's all for the classification algorithm. At least, okay, this is how it works. And the rest of the thing is actually how to print out a graph. Okay, so I will just try to run this. So even for simple program, it takes time. So there is a deprecation warning here in this particular program. Because I was using the previous version of Anaconda when I wrote it. Okay, so he is able to predict that, okay, it is yes. So this is the data set, and those are all the attributes. Okay, the target values, these are all the input attributes, and he predicted yes for that particular correlation, a particular vector. You got it? Wait. Okay, yeah. So 50 and not married. You got it. So you take the data set, identify the labels and features. Features are the input variables and labels are, okay. You take the features and you take the label, and then, okay, you put it into the fit function. You will be able to predict the model, and you can use the predict function. This is pretty much same for most classifiers. There is a pattern in it. Okay, so you can actually exploit it. Go to scikit-learn There are excellent programs, but you will be overwhelmed with it. Okay, take one at a time, chew one at a time, and you will be able to do it. Okay, this is how you work with decision tree. Okay, so next I will show you something called naive Bayes. Naive Bayes. Okay, how many of you heard about Bayes theorem? Okay, so Bayes theorem is about what? It's about probability for sure. Okay, so what exactly? Can you tell in plain English or Malayalam? Okay, or English? What essentially happening there? See, there is a notion called a priori probability, or before you run the experiment, you know that probabilities of one particular event happening is X, and all of a sudden you found out a new fact. You should adjust the probability. You should adjust the probability. So Bayes theorem helps you to do that. So that is the basic idea. So you are actually readjusting the probability based on a fact, so that you can calculate the posteriori probability once you have understood the fact, or once you have created the, so that is the intuitive understanding. Okay, so Bayes theorem has got a lot of application in drug testing and all. Okay, I'm not getting into that. Okay, so for that, what I'm going to use, I'm going to use a package called R. How many of you heard about R? Okay, R is a statistical workbench or a program which has got lot of packages where you can actually do some kind of a exploratory data analysis. Okay, so let me go to Wikipedia. There's an example there. Okay, so I will actually, based on that, I will actually explain. So at least, okay, before it gets rooted. So far we have learned about rule-based classification. You don't have much doubt about it, right? You just actually observe the data and try to pick rules. And if your prediction and the given data has got a delta, you should readjust the rules until you get it correct. So that is a rule-based classification. The next thing we learned is a priori algorithm, which is one of the easiest but most profitable one for market basket analysis. Okay, where you actually generate lattices. That is called, technical name is lattice. Or you generate a graph. You can use breadth first. You can use breadth first traversal to find out the superset and then find out support and confidence. Then we learned about decision tree. The way the first 20 questions or okay, those kind of programs work. You sieve the data based on, you split the data based on criteria. So you have to look into certain things. Okay, so in this particular case, we are going to use an algorithm called naive Bayes. Okay, so Bayesian statistics is about adjusting the probability once you have performed the experiment. Prior probability can be adjusted to posteriori probability based on the evidence received. So why it is called naive Bayes? Because typically Bayesian analysis can be done on dependent phenomena as well, dependent variables as well. Moment you bring in interdependence between variables, you need to do subtractive elements of the summation. So what happens is, it is in this case we are just assuming that it is independent. So moment you do that, you just multiply the probability. You don't have to look into the double counting aspect. You getting me? So to use naive Bayes, okay, I don't know why it is not coming. Okay, I don't know. So basically, when you speak about naive Bayes, okay, there is an example in Wikipedia. I was planning to show it, and I was planning to use R because R has got a package called E1071. E1071, where it has got a naive based classifier. You just give the data the way you gave in a CSV file. He will be able to do the prediction. Okay, it's a 4-line program. Okay, unfortunately, I don't know what has happened with my machine. You're able to see that? Huh? Okay, so I will do one thing. Okay, I will actually see. Unfortunately, I could show you only 2 algorithms. Okay, a priori and decision. Okay, so this is a simple data set, okay, where you have got the height of the person, the weight, and the foot size, and then you are predicting whether it is male or female. This is your data set. Okay. So we are actually creating a binary classifier here. You are actually predicting a yes or no or male, female, okay, binary classifier. See, the moment you got this data set, you can do some exploratory data analysis, and you can find out that the mean height of the males are 5.85, females are 5.417. Like this, you get the statistics of all the 3 dimensions or attributes in this particular data set for males and females. Okay, he is computing mean and variance. What is variance? Square root of variance is standard deviation, right? Okay, variance is actually standard deviation square. Okay, so how to compute standard deviation? I got a program, okay, but I think I have seen mostly you know about it. Okay, so once you have got this data set, you have got a sample data 6, 130, and 8. So you should predict whether it is male or female. Before I get into the details of the algorithm, let me put this data set into R. And show you that you will get the same result, which Wikipedia says that the data set vector set is actually data set is. Okay, so let me show you how to actually load this. So this is the okay, so I have actually converted the data, pasted the data set from there to here. Okay, and let me show you the program which I. First, I did load the library or the package, okay, given by. So, okay, I am using an older version, okay, because that's why you are getting this morning, but still it works. So next is you are reading the data set, CSV file, and you are training the. See, first I will load the data set. Okay, once you have loaded the data set, you can actually use the naive Bayes classifier. So it's an R is a functional language. Okay, it has got its own unique sentence. Index. Okay. The gender is the output variable, and then okay, you are giving okay. These are all the inputs data. So now you have trained the model. Okay, let me print the model. Okay, so he's giving priori probabilities, male, female is 0.5, and then okay, he's trying to calculate the posteriori probability, the way I was telling. So what you have to do next is okay, you can actually since I didn't exactly know to create a data frame from hand very fast. Okay, so what I did was I called the table function in R. Okay, so where what was the our output the test variable? It is 6, 130, and 8, right? So I am saying 6, 130, and 8. Okay, so now I am going to set the frame. So it actually predicted that it is linear. Okay, so this is so basically even if you don't know much about the naive Bayes algorithm, and even if you don't know about decision tree, you can still train decision tree, and you can actually use these algorithms. So that is the idea here. So once you play with data, then you can ask others, okay, how it works, and slowly you can figure it out rather than trying to learn everything by go. So how many of you have tried to take a course by Andrew Ng? Okay, so I always tell if you meet Andrew on the road, kill him. Okay, so the problem is I haven't seen anyone doing machine learning after doing that course. Okay, so practically speaking, the problem is it is not a fault with him. If you are an academic, you are supposed to obey mathematical fidelity, right? Or you should actually be mathematically accurate. Otherwise, his reputation will go for a 6. So the first program which shows is actually stochastic gradient descent. So, see, reason why I studied machine learning recently, because whenever I went for session, I will see lot of sigmas and then matrix formulas. And the presenter will be speaking about it. And I haven't seen any correlation between what he speaks and what is there on the stage. So then I realized that, okay, a lot of people are actually, I don't know whether they understand what they speak. Mostly, okay, some people do know it, but they don't know how to program as well. So the problem is, okay, their knowledge is sometimes useless. Okay, so why I am telling it, the first thing which comes to Andrew Ng the course is linear regression. Okay, I will show you how to reason about linear regression in a much better way. So I am moving a bit fast. All you require is one line of NumPy code in order to solve the linear regression problem. So try to contact a programmer, and I'll show you one screen snapshot, okay, which I created for this session. Am I making sense here? At least, okay, you understand that there are other shortcuts to learn this, right? Yep. Thank you. So you have to learn a bit of matrix algebra to reason about linear regression, or for that matter, regression in general. Okay. R is actually greater than 1, right? Okay, so before I don't think, oh. Okay. So this particular equation you might have seen in Andrew's slide, right? So basically, what happens is you cannot you cannot multiply matrix just like that. Matrix has to have certain kind of properties. So what happens is, if you want to take an operation like inverse, the matrix should be a square matrix. So what these guys are doing is they are transposing the current matrix. That means row and columns are interchanged, and they are multiplying with the matrix so that okay they can get a square matrix, and they are taking the inverse and multiplying with the transpose to figure out the beta or the slope of the linear equation for one variable case. So all you have to do is okay, read this statement. See, you see something called dot product. That is a synonym for matrix multiplication. Why? You are actually taking dot products basically. You are taking a linear combination. So what happens is if you are able to understand this, see you are taking a transpose, then you are actually multiplying with a y matrix so that you can actually get this. And here what you are doing is you are transposing x and then multiplying it, and that is fed into dot, and then inverse is calculated, and that matrix is multiplied with this one. You got it? So linear regression need not be that tough as it appears in Andrew NG slides. But see, the reason why I named street programmers means we don't have the prerequisite to learn that course. How many of you agree? At least I agree that okay, we don't have the right prerequisite to learn. See, there are two courses. One is a Stanford YouTube course, which you don't go. Okay, you are never going to. You are not going to understand. But if you go for the other course, okay, he has made it much more simpler, but still it is actually more than what you could do. But once you do this, then go and actually attend these sessions. It will make sense. And I would like to mention one more course from Caltech by Yasser Abu Mustafa. How many of you have seen his course? Okay, that course, which I found, okay, at least maybe for my cognitive taste, I found to be much more coherent with my worldview. And it is theoretically a bit more involved, but try to do a lot of scikit, R and all, play with the data, understand terms like bias variance trade-off, what is overfitting, underfitting, and what exactly happening. Once you have done that, try to take Andrew NG course, you will fail mostly. Try to go to Yasser Abu Mustafa, you will fail there as well. Then you ask, okay, with people, and slowly you gain confidence. And okay, one thing is, there is a particular paper called Top 10 Machine Learning Algorithms of the World. How many of you heard about it? Top 10 machine learning. So if you go through it, 8 of them do not involve much math. And couple of them which has got math, you have got good libraries like NumPy, or else okay, JAMA in Java, or there is something called Forge in C#, where it gives you routines for eigenvalue computation, singular value decomposition, all matrix factorization method. Once you have got it, and if you are willing to treat things as a black box, you can play with it. Once you understand how conceptually things work, you will be able to do it. And there is a particular book called Machine Learning in Action, which implements 8 of the algorithms specified in that 10 in Python. So port that into language of your choice. Peter Harrington has done a good job. So you can actually learn machine learning. So to sum up, I told that analysis synthesis model of thinking has got limitations. You agree with me? Because it assumes something called independence. So system thinking actually takes it into consideration the whole, it is taking a holistic affair by taking a step backward. The problem is that it is not mathematically amenable. So basically we do not have any other recourse but to fall into linear models. And then, okay, I showed you the simplest algorithm. I in fact showed you Tom Mitchell's definition, which I found to be very intuitive. And then I talked about rule-based classifier, which everyone can follow. Basically, we are doing rule-based classification mostly. Then, okay, there was actually a discussion on a priori algorithm, where I showed you a routine, okay, which I wrote, where I created test data set, training data set using an algorithm. And I don't know, even if I took a random number generator without taking into consideration the mean and standard deviation, still I could get reasonably coherent data, much more in tune with real world. Okay, so after that, I showed you how decision classifier works, and then introduction to naive Bayes. At least you got a vocabulary. So this particular thing has to be taken as a workshop to make full sense. So I assume this thing was useful for you. So that's all from my side. Thank you.
So any questions on the session? Doubts or clarifications, anything?
So personally, I've got a lot of books on fuzzy logic in my shelf, but still it looks like very new. Okay, so I don't have much idea about it. So fuzzy logic and related things come under something called soft computing. So fuzzy logic, it is rule based, where they are actually trying to move. See, traditionally we do some kind of a reasoning using naive set theory, and bivalid logic is applied. In the case of fuzzy logic, they are taking into consideration the states between. It's a many valued logic. So I don't know whether it can be called a machine learning function, but it comes under the category soft computing. Okay, it is at least thought in it. I have got a couple of books with me, but I am not in a position to comment on it. Anyone? Okay, who has done fuzzy logic?
So I'd like to understand, or maybe for the benefit of all, how what you explained is different from data mining. So we have, I find that these are many of related to the data mining algorithms or the way we do things. Second point is that I have, maybe I don't have much experience with the machine learning or artificial intelligence or deep learning, but I have seen something called TensorFlow, which is a Google's open library, and there is a playground as well. So I could see that there are the data sets are being automatically getting classified by adding more. I mean, probably the speed of classification increased by when we add more neurons in the cluster. I mean, whatever it is. So how this all derives to machine intelligence or artificial intelligence or maybe deep learning kind of things. So maybe it's like machine learning is a too broad topic, but when it comes to the products where we integrate, now if you look at the cloud platforms, you can see there are many players out there like Amazon, Google, and all. They are exposing their machine learning and computer vision algorithms there. What do you think of this? Like how we should get started as like when we say street programmers, should we really get started there, or should we get started with this kind of tools? So there are a lot of questions I have. So
okay, so it's a broad question. Okay, let me try to, because I'm not an expert in most of them. TensorFlow I have just only heard. I don't have much, but let me take a stab on that. So it's correct that, okay, what he told is correct, that most of the algorithm which I mentioned comes under the category of data mining. So at least, okay, my personal view is data mining is nothing but applied machine learning. So when you say machine learning, it has got two aspects. Even if it is, you take mathematics as well. There are some people who create more mathematics in order to actually reason about things, and there are people who apply it. So when you say about machine learning, a course in Stanford or Caltech. Okay, they are actually trying to create more machine learning researchers. Okay, so you will see more math there. But what I have shown you is mostly from a programming perspective, where if you take a look on, see, most of my examples, or I learned about, okay, machine learning from data mining books. Okay, so a couple of machine learning books which I am having is too mathematical. I haven't seen much source code in it. Okay, so I'm not in a position to comment exactly on that, but my personal belief is machine learning is applied mathematics. Okay, so the next question is, okay, I don't have much idea about the TensorFlow, but I will reason about the offerings between Amazon Elastic Search, right? Amazon machine learning. Okay, and then you have got Azure ML, and then Google's BigQuery. Okay. Oh, now they have actually so what happens is these vendor offerings are good for scaling your solution. I don't think that, okay, even if there are tutorials in it, some kind of an assumption made on you that you understand what you are doing. So I don't think that, okay, Spark, okay, you have to learn at the comfort of a virtual machine provided by Cloudera or something. You get familiarity with it, and then, okay, you scale your solution using that. So things like NumPy and SkyPy helps you to understand the conceptual underpinnings between what you are doing. So what I would like to suggest is, okay, you take a look at see, when you say about machine learning, it is machine learning algorithms is what I have told. I haven't told you how to actually do data analysis. Okay, I have shown you some use cases of machine learning, but in a real life situation, okay, you need to find out something called outliers. Okay, a data which doesn't fit into the normal stream, and then, okay, you should be doing extensive dimensionality reduction in order to make the number of columns manageable. So what happens is there is an applied field called data engineering, which happens to that. But if you want to reason about machine learning, I don't think that Azure ML or others will be is a good solution. You either start with the NumPy and R, and then, okay, you can use virtual machine provided by Hortonworks and all. You play with it, and then you try to scale solutions there. So that is what I would like to suggest, or at least based on my learning. Okay.
Maybe I can paraphrase here. So basically, what I have understood so far. So basically, from what I'm hearing from this particular session and from other places also, is that so you've got a lot of algorithms, you've got a lot of package solutions, you got vendors, you got Spark, you got all those places, and it's becoming easier and easier to basically, like you said, scale your solution or actually implement your solution. You can go to an API, give the data, and expect some response. But the key in all of this seems to be deciding which one to use, right? Okay. So you get a raw data set. How do you figure out whether you want to do like your decision tree, or you want to do random forestry, you want to do software vector, vector graph, whatever it is, the vector machines and all that stuff. So the bigger what do you call it, role for a data scientist or for a machine learning expert seems to be more about taking the data set, creating this, getting the sample out, understanding all the features, and figuring out exactly what is the model that would work, and then testing that. And then basically the implementation becomes kind of like the 20% of it at the end of all that research.
Yeah, see, it's a good way to summarize it. There is a tool called Veka. Okay, so I'm having on. So what you can do is, okay, what I did was, I got a lot of data set. I fed up, okay, to reading the description. I took one data set, fed with 5 or 6 algorithms, and find out which one was the best. So I saw, I found out that decision tree is actually making good. It is predicting 95% of the time. So when I looked at it, it was categorical variable. So what happens is, even if you don't have much idea about it, you take a machine learning package, play the same algorithm with all the algorithms, and figure out to yourself. And then you can do a retrospective analysis. See, it is very sexy to say that, okay, I can just, moment you sit there, he'll be able to find out, okay, which algorithm to do it. You can empirically verify it. So Veka has got a command line option. You can even write a batch script in order to automate that. So what I feel is, you download that software FAYA, and there is a MOOC course, okay, which is much more easier because they are using on, and there is a particular book called data mining. Okay, once again, okay, like you said, okay, it's a data mining book. You play with it, and then you see. Frankly speaking, I played with my first neural network yesterday. Okay, because I haven't done anything with it. FAYA helped me. And I saw that, okay, in video and all, okay, they are able to show graph. I figured it out for 1 hour, and finally I found that, okay, GUI is equal to true. I have to put it, okay. I got it, presto. So what happens is you can do a lot of exploratory analysis using FAYA, which is a free software. There is a book associated with it, and it is much more easier to learn. So you can actually do like that. Okay, so I'm still learning. Okay, so my interest in it is to enhance my reasoning ability about, okay, statistics, maybe my algorithmics. See, I don't know whether when I will get my first opportunity to work on a big data project. Okay, I worked with extreme analytics in the past, and even hierarchical clustering for a software where, okay, I was using creating a user interface. But so what happens is it's a learning process. The aim of my session was to show that programmers can also learn machine learning. Okay, so that is what my idea. Okay.
So it was a good session, and like one point that I wanted to raise was you were talking about Azure machine learning as well as Amazon machine learning. So we have internally at our company, at Diagonal, we have internally used Azure machine learning as well as Amazon machine learning. Amazon machine learning, like you said, it's more about scale. It uses a logistic regression technique. So you feed in a model, but you really don't know what happens underneath that model. So it just works. But honestly, I have found that useful in the products, in real life applications in that sense, because say for me to build a recommendations engine to understand whether to use a decision tree or a different algorithm, it was getting more complex given that I'm from a programming background. Azure machine learning takes it to a next level where you can have a marketplace. Say applications of machine learning could be even a bit higher, right? Like collaborative filtering, like semantic analysis and churn analysis kind of stuff. So, so the algorithms that you have mentioned are used in collaborative filtering and churn analysis and all that, but it's a level down. So, so yeah, for me, I found it to be just one more level up. I know that it's not the actual way of learning machine learning, but at least it's helpful for people to get a software out there or get a API out there for the customers to use. I found that the tools or the cloud solutions or the platform as a services like Azure machine learning and Amazon machine learning has been quite helpful.
Yeah, so I agree with you. And see, sessions like this can help you to reason about it, okay? Or at least, okay, you can qualify for a couple of interviews for sure. Okay, maybe someone who knows about linear regression, then stochastic gradient descent, okay? So, at least this guy has heard about something, okay? So, he might qualify for that. So, see, it was like, okay, when SAP came, it was very difficult to work with it. Some people were lucky. So, like that, okay, in machine learning also, I'm seeing such a similar thing. You happen to work with a company and all of a sudden, okay, some solutions come, okay, then you are part of it, okay, then you're suddenly you are actually related to something called machine learner, okay. There might be guys who are good at statistics and math, okay, they might not get opportunity. So look for your opportunity. See, when opportunity meets preparation, it is called luck, okay. So it is, I think in the coming years, the lingo of machine learning and other things will be very common, and then it will be like ABCD, okay. You should understand, okay, what is a regressor, what is classification. A priori is not, a priori is, okay, there is a philosophical term called a priori, okay, but this is a noun, okay, for algorithm. So now you understand that how Walmart are able to predict, or why your supermarket guy is giving you a card and a discount, to understand your, or understand the purchasing propensity of people, the class to which you belong. They are not going to do a particular analysis on you. So they will be classifying it because there are privacy issues. So let's hope this was useful. So I think we'll wind up, and then there is a couple of things after this. Okay, thank you.
Well, that was a really fruitful session, and we really appreciate the patience you have shown to clarify each and every doubts we have raised. So now, as a token of appreciation, I invite Mr. Deepu Esnath, the Managing Director, FAYA India, to present a memento to Mr. Praseed Pai.
So, Praseed, thanks a lot for coming down to Trivandrum, and I think you were in you were in Kochi, right? Okay, and taking out your time to take a valuable session here. So this was just like a very introductory session, just to introduce machine learning and get familiar with some terms. And of course, that is even much more. And I think that is we will be able to start to try something in machine learning from this after this session. Okay, and thanks a lot. And here is one small moment for you.
They are having all the worship. Still, I haven't learned much. Okay. No. See, you know one thing. Most of these are good. Around from 1990. And by the way, people know me is formal R&D director of Google. So this is a difficult book. Let me see the name of it. Give us So I'm having the third book. See, somebody listed this copy and I got it back. Okay, so now I put it. But this is the thickest one.
Okay, so thank you all for sparing your time and actually showing interest in our session. And to conclude, I'd like to say that FAYA 480 is always about three things. It's about gaining some knowledge, sharing it, and meeting a group of like-minded people with whom actually you can interact and expand your networks. So now I'll say that all of you are being brought under one roof based on your interest for machine learning. So it's a fertile ground for you to network. So make the maximum out of it. And to stay updated with the latest technology advances, you can join our Facebook page, Techno Geeks. And to improve the further sessions of FAYA 480, we will be sending feedback mails to each and every one of you. So please do give your sincere opinion so that the next session will be a much more better one. And I hope the session was really interesting and fruitful for each and every one of you. Thank you. Thank you so much.